Hey, I am the math professor, Kyle Martin, and today we're talking all about absolute value in our inequalities series, okay? So we're gonna tell you what they are. We're gonna go over steps to solve them. There's 3 of them, right? Then we're gonna give you 2 examples, as well as remember, there's timestamps in the video player down below. You can take that little red dot, drag it to whichever part you need. If you only need the examples or only the steps, go to whatever part. Let's get into it. All right, so what are they? What are absolute value inequalities? Okay, a quick definition we're gonna use for this video, all right, is just the distance the set of solutions is away from 0. Okay, so remember back to just regular inequalities, that was a range of solutions, right? If you had x is greater than 4, right, x could be 5, 6, 7, 8, anything bigger than 4 would satisfy that x. It'd be a solution of that inequality. So here, when we have absolute value inequalities, let's kind of take a look at 2 different cases. Here we have x, the absolute value of x is less than 2, and then on this one, we're gonna have the absolute value of x is greater than or equal to 2. All right, so in both cases we're using 2. And what this means, if the absolute value of x is less than 2, that means whether it's negative 2 or positive 2, since absolute value doesn't matter if it's negative or positive on the inside, we're going to have open dots at each one. And then we want the answers that are less than that away from 0. And the only ones that are less than that away from 0 is if you shade towards 0 on the left and towards 0 on the right. And you're stuck with this range that's in between negative 2 and positive 2. Right, for this one, the absolute value of x is greater than or equal to 2. Same idea, except they're going to go in the opposite direction. So negative 2, positive 2. Greater than or equal to is going to have closed dots. So here we need it greater than that distance away from 0, or greater than 2 away from 0. So over here is farther than that from 0, and over here is farther than that from 0. So you'll notice a couple things, all right? First off, we end up either going towards or away. And so it's going to end up being a compound inequality. For all of our absolute values, they're going to be compound inequalities. Okay, second thing, this implies distance. Distance, we know, cannot be negative. So we're going to learn in a little bit that if you have an absolute value that's I shouldn't say equals, but that's either greater than or less than or whatever, to a negative, that's going to be a no solution because it cannot be negative for the distance. All right, here we have our 3 steps to solve these absolute value inequalities. Okay, the first step, we need to isolate our absolute value bars. Okay, so we're going to do this example here in a second, but our absolute value bars are obviously those vertical bars that go around, usually your variable. Okay, secondly, we need to create both cases, and we're going to talk about this here in a little bit, but we're going to have a positive and a negative case. Because remember, the absolute value of something, whether it's positive or negative, is going to yield the same result. So we need to create both cases to start with to see maybe where that did come from. And then lastly, we need to solve, graph, and write the interval notation. Some teachers may be a little bit more picky as to what you do. I have my kids do all 3. So let's try it here in example 1. Example 1, it says the absolute value of x minus 10 is greater than or equal to negative 3. So my first step, remember, I need to isolate the absolute value bars. What I mean by that is everything on one side of our inequality can only be the absolute value bars. So right now they're right here, and you can have anything inside of it, but if there's anything outside of it, that has to be moved to the other side. So how can I move the minus 10? Well, I'm going to add 10, and I'm going to add 10 to both sides. And when I do that, that's going to give me the absolute value of x. Now it's currently isolated because that's gone, is greater than or equal to, this would be a positive 7. All right. So once we have those isolated, then we're going to create both of our cases, a positive and a negative case. The way I like to do this is to make 2 arrows going to either side. And in my first one, when you do these 2 cases, you're going to drop your absolute value bars. So I'm just going to put x and then write it exactly like it looks, greater than or equal to 7. So the only difference between this line and this line is that there's no more absolute value bars. Okay, and then for my negative case, same idea, drop the absolute value bars. But this time you have to flip your sign. So instead of greater than or equal to, now it's less than or equal to, and then you're going to make your answer negative. It was positive, now it's going to be negative. All right, and then we need to solve, graph, and write the interval notation. Well, these are already solved for. Since there's only an x on the inside of our absolute value bars, there's nothing else we could do. There could be more stuff in those bars, which we'll do in example 2. But for right now, that's already solved. So to graph this, we're going to graph these together on the same number line. Okay, so in this case, we just have 0 in the middle, and then negative 7 and positive 7. If I do that, and let's see, x is greater than the positive 7, greater than or equal to, so closed dot shaded to the right, and x is less than or equal to negative 7, so closed dot shaded to the left. Okay, and then lastly, the interval notation of this, well, there's two snippets of our shading. So this is going to be from, this snippet is going to be from negative infinity to negative 7. Both get, or this one gets parentheses, the closed dot gets a bracket, right? And then union with our other set, which is going to be from positive 7, again, that gets a bracket, to infinity with a parentheses. All right, guys, number 2 I want to make pretty challenging. So we have a lot of parts going on here. It says negative 5 times the absolute value of 2x minus 4 plus 3 is all greater than negative 7. All right, so my absolute value bar is what I need to isolate. That's my first step, remember? And so we need to move this 3 and this negative 5 to the other side. And if you remember, since this is being multiplied, we actually have to move this over first. All right, and if I do that, I'm going to subtract 3 on both sides. Those cancel. So now negative 5 times the absolute value of 2x minus 4 is still going to be greater than, but this time negative 7 minus 3 is a negative 10. All right, again, this is being multiplied, so to undo this negative 5, I have to divide by a negative 5. And these are still inequalities, right? This is still in our inequality series. And so remember that when I multiply or divide by a negative, my sign's going to flip. Right, so I still have the absolute value of 2x minus 4 here. Let's see, sign flips because I divided by a negative. Negative 10 divided by negative 5 is a positive 2. Okay, and then, let's see, it's finally isolated. So now I can make my two cases, my positive and my negative case. If I do my positive case over here, my negative case over here, that's going to give me 2x minus 4, right? Just like it looks inside your absolute value bars. And then minus, or is less than 2, you're just dropping the signs, okay? On the other one, we're going to go 2x minus 4, again, dropping the bars, but then the sign flips and the 2 becomes negative 2. All right, then I can solve both of these, and then eventually I'll graph and write their interval notation. All right, so I'll save the trouble, I'll just do this real quick. All right, so I went ahead and I solved both of these. You have to solve them both separately. And when I did that, I got x is less than 3, and over here, x is greater than 1. All right, so when I go to graph this, I'm gonna have, if this is 0, these are actually both positive, so maybe we'll put 0 over here, call this 1 and call this 3. At 3, I need x going less. So it's going to be open dot shaded this way. At 1, it's going to again be an open dot, but this time it's greater than, so it's shaded the other way. Remember I said we're going to end up with compound inequalities? Here, these are going together. This is an and compound inequality. My compound inequality video I'll put right here for you if you need that. But anyway, the interval notation is the snippet of this graph, and so we're just going from 1 to 3. They're both open dots, so they're both going to get parentheses. All right, now I got a bonus problem up here for you. This is number 3, and this one's not going to take very long at all. I'll show you why. Okay, here, to get our absolute value bars isolated, I'm going to subtract 6 on both sides. I get the absolute value of negative x minus 6 is less than, since those cancel, is less than negative 1. I can stop right there. Remember, absolute value implies distance. Distance can't be negative, so therefore, this is no solution. Absolute value cannot be negative.